remember any.
It's okay. You guys can record away.
Yeah, thank you.
바로 인터뷰? 바로?
뭐부터 시작할지 물어봐.
질문
일단 데모 보여줄지. 뭐부터 시작할지 물어봐.
Can we do 인터뷰 먼저 하는 게 낫지?
First interview first?
Yeah.
First question is what is Selling's current biggest and final goal?
You me or should
I can go. Yeah.
you go?
Yeah.
So, as you know, Cellink is a bioprinting and biomaterials company.
Yeah.
So, first and foremost, what our goal is to enable researchers, physicians, industry organizations to use bioprinting to achieve whatever their goals are, whether it's to take a pharmaceutical product from the research phase quickly to the market and make it a higher success rate, or to allow a researcher or a professor to understand the human biology better. So that's what we do as a company. And I'd say our vision, our long-term goal, is to aid in stopping the dependency on live donors for organ transplants. So we want to help the community, the bioprinting community, get to a point where fully functional bioprinted organs are a reality. And so we address the issue of organ transplants. So I'd say that's a big picture. What do you say, Gusten? Concur?
No, yeah, absolutely. I think that sounds very correct.
Great.
How will vascular bio ink affect the success of future bioprinted organ transplants?
Yeah, so that's a good question. I think vasculature is probably one of the biggest challenges that we face today. So when we talk about being able to create a fully functional organ, one of the biggest limiting factors is we can't create vascular networks to feed those organs and have them sustain for a long period of time. So a vascular bioink is would be a great step towards getting towards those functional organs. It would allow us to produce better quality prints, more complex prints, and things that are more physiologically relevant. So I definitely think it's an important step that we have to take, and hopefully one that we'll be taking soon.
I think that one pretty exciting thing that was released yesterday in regards to this is one of our collaborators got a publication in Science magazine where they published an article where they print vasculature. So that's vascularized tissue that they printed, lung tissue. And this is enabled by one of our bioprinters and a bioink that we provide for researchers to use today to print vasculature specifically. And this kind of prints is what's going to enable, as Avi said, to really enable you to print fully functionalized tissue.
So it's definitely twofold in that you have a vascular bioink and you also have different styles of printing which allow you to break down that challenge. And as you can see, it's being done on our machines and our material. So yeah.
And I saw in your home pages, unlike other organs, I saw that skin has a special design for printing it. So is there any special reasons for it?
Yeah, well, printing out organs fundamentally is the same thing. Skin is a very important organ, and so that's what we have on our website because it is something that there's a lot of interest for. So we have tailor-made materials to allow you to print skin, and so that can be used in functions like wound healing, burn victims. The thing with skin is it's a multi-layer tissue, which you can replicate well using bioprinting. So that's something that we're already doing very well. And the way it works is you have a typical model is 3 layers. So you see we have 3 different extruders. You can use 3 different inks and 3 different cell types to build up something that replicates skin very well. So in terms of what's different about it is that it's something that we can do well, and we're getting better and better at it. And the protocol as such, though, is still the same for all different types of organ printing. You still want to create a biomaterial or a bioink that resembles the human body as closely as possible, and then print that out into obviously a sterile environment, but in a physiologically relevant construct. So with skin that's a couple of layers of different styles of cells. With say a lung, like we saw in the other study, the difference is you want a vascular network around it. So you have to think of what you're trying to print and then try and come up with the most exact model for it.
How long do you think it will take to have a successful transplant of a bioprinted organ?
That's the $1 million question. I believe experts within the community, the prediction is for a fully printed, fully functional organ is actually 10 years. So not very long. But from that 10 years, the point to get it to a clinic setting will still take some more time. So I think the technology, like we've seen, we're getting better at printing it. And us at CellLink, what we're doing to allow that to happen, to shorten that timeline, is we're approaching it from multiple different ends. So we have our extrusion-based printers, we have our DLP-based printers, we have our wide portfolio of materials that we're using. So to get to a functional organ, we're trying to shorten that time. I believe right now the estimate is 10 years. And then from that point to get it to a clinic setting, it will take things like